All right, so let's see if we can't figure this out. It says water is leaking out of an inverted conical tank at a rate of 7,700 cubic centimeters. So as I read through this, I'm going to try and list all the information we have, kind of like they did in the video. So we have dV out over dt. The change in the volume, because water is going out, over the change in time is equal to 7,700. We'll just say cc per minute, cubic centimeters per minute, at the same time that water is being pumped in. The tank has a height of 6 meters, so this height here is 6. But I want all my units to be the same, so I'm going to keep everything in terms of centimeters. So 6 meters is the same thing as 600 centimeters. So we'll say h of the tank is 600 centimeters. And the diameter at the top is 5.5 meters, so this is 550 centimeters. So we'll say, oh, that's the diameter. So the radius is going to be half that, which is 550 divided by 2, which is 275. So the radius of the tank is 275 centimeters. Let's see what else. The water is rising at a rate of 18 centimeters per minute. So this change in the height of the water, dH dt, is 18 centimeters per minute when the height of the water is 1 meter. So this is going to be 100 centimeters. And this is the radius of the water. This triangle represents the water. So in the video, they set up similar triangles to try and figure out a relationship between R and H. So let's do that. I'll replace this with H for right now. Okay. So then if I leave this as H instead of 100 to get a relationship between R and H, I get the parts of each triangle in a ratio form should be equal to each other. So R over 275 should equal H over 600. So if I cross multiply and solve this, I get 600 R equals 275 H. Now in the video, the instructor solves this thing for R. I'm sorry, he solved this thing for H to replace H in the formula with something involving R. But we have dH dt. So it would be easier to just solve and get rid of R in our equation and only have H's. So that when I go ahead and do this, I don't have to solve for dr dt. I already have dH dt. I don't need dr dt. So I'll show you what I'm talking about. What I'm going to do here is I'm going to solve this thing for R. So then I can replace R in my equation or my formula for volume of a cone. Volume equals 1/3 pi r squared h. I'll replace R with something so that when I differentiate this formula, I'll only be left with dH dt and h's. So solving for R, I divide both sides by 600. I have R equals 275 H over 600. And I'll just reduce that real quick. I'm going to cheat a little bit just to save some time. 11 over 24. So this is R equals 11 over 24 H. So what else am I looking for? Okay, when the height of the water is 100 centimeters, so we'll say height of water is 100. And we're looking for the rate at which the water is being pumped into the tank. We're looking for dV in over dt. Okay, so I'm going to take my formula for volume of a cone, and I'm going to replace R with 11 H over 24. So I have V equals 1/3 pi r squared. It's 11 over 24 h squared times h. So we'll do 11 over 24, and we're going to square that. Whoops, let's do this. I want to do this. Okay, times 1/3. So I have v equals, we'll leave the pi on top, pi over 121 pi, sorry. 121 pi over 1728 times h cubed. So now I only have h's and v's. So when I differentiate, I'll have dv, which is what I'll have here when I add these two together, and dh. So let's differentiate this thing. V becomes dv over dt. This 121 pi over 1728, we can leave that there for right now, times 3h squared dh dt. So I can multiply the 3 by that fraction to clean it up a little bit. We'll do this times 3 and keep it as a... Okay, so we have dv dt, which, if you know, is that's the rate of change going in plus the rate of change going out. So let's find a different color. So this is dv in over dt plus dv out over dt equals 121 over 576. That's the 3 times this, h squared dh dt. Okay, we've come a long way. Now we have everything we need except for dv in. So let's rewrite this again. dv in is what we're looking for. dv out. Oh, this is negative, sorry. 7,700 equals 121 pi over 576. H, the height, is 100 squared. dh dt, which we had, is 18. So I'm just going to put this whole ugly thing on the right into the calculator. Let me see if I can move this to get a little bit more space. Okay. So I'm going to do 121 times pi divided by 576 times 100 squared times 18. That's this whole thing. And I get to get dv in over dt by itself, I'm going to add 7,700 to both sides. So I'm left with dv in over dt equals 12,6491.47. And this is cc's per minute. Okay.